Hey everyone, so today we're going to be performing a fire flow test by making a model in WaterCAD. So first things first, we have a site here that has a Harris teeter right in this space. And then we also have a fire hydrant located right here where a flow test was performed, which we have the form pulled up right here. And then we have an existing 6-inch CIP line going into our site with an 8-inch PVC fire line. And this is a backflow preventer, which we'll touch over once we get into WaterCAD about how to model that properly. So you want to bring in a couple of things to kind of clean it up before you import this into WaterCAD. So what I've narrowed down is the finished grade contours, the water, or I guess the fire line with the fittings, the backflow location, your fire hydrant, and your existing your existing water line. So first things first, we're going to use the break command to break up our polylines where there's a fitting. So type in break, click the polyline, type F for first point. We're going to click this twice. 1, 2, and now we're good. And you'll notice how we're broken up at that T since this existing water line keeps going past this fire hydrant. But we just want to simplify it to just for our own benefit once we bring this in to WaterCAD to have the least amount of clutter in our WaterCAD file. So now we're going to go ahead and do this for all of our other fitting locations. So break again, first point, and just click twice. You'll notice how we're broken up. So keep doing that for all the other ones. Okay, one more. Alright, so now we're all broken up, but we need to make a surface real quick so we can add elevations since WaterCAD needs elevations to use in the model when running the fire flow test. So I actually already have a surface set up and all my contours are already in there. So let's just rebuild this. So now we're going to select the surface, add labels, spot elevations, and we're going to put it at the fire hydrant where the flow test was performed and at each of the fittings. Okay, so now that that's over, go ahead and save your DWG, and now we're going to save this out as a DXF, which this is the file type that WaterCAD uses so we can actually import a DWG or just an AutoCAD file. I guess it's a DXF in this case. So we have to save it out as a 2004 DXF since that's all that WaterCAD can really handle. So go ahead and save that out. So now that we have our file in a DXF format, we kind of need to clean this up. So let's go ahead and delete the surface out. Oops. And we're going to just select similar to delete all these contours. And we're going to go ahead and delete our fittings. And note that we're going to be bringing up the DWG for reference when we're putting in our elevations into WaterCAD. So now this is going to look a lot better when we bring this into WaterCAD. And also note, I've changed the layer names to reflect what they actually are, since WaterCAD will be reading what the layers names are, and so it'll be adding labels. So just to make them a little nicer, I just went ahead and named them to actually what they are, followed by the material. So since this is an existing sync CIP, I just reflected that in the layer name, and I did the same thing for the PVC, or for the fire line in our site, 8-inch PVC. So go ahead and save that, and we'll be bringing this into WaterCAD now. So after opening up WaterCAD, we're just going to create a new project. And once this is loaded, now we're going to import our DXF that we saved out as from the DWG and AutoCAD. So to do this, you're going to go to Tools, User Data Extensions. You're going to right click on Pipe, Add Field, and then just name this AutoCAD layer. And leave everything else default and hit OK. So then go back to Tools and go to Model Builder. And now we're going to make a new model builder. For your data source, select CAD files, and then just browse the DXF that you created. Hit open. And notice how these are the layer names that WaterCAD drew from AutoCAD. So these will actually be the labels that generate for our pipes. So moving on, right here, we're going to select establish connectivity. So this is just in case, for whatever reason, if your polylines weren't snapped properly, they'll all be connected. Leave that font. This is okay right here too. Alright, so now we need to have our layers be recognized in WaterCAD properly. So to do this, we have to do this for both layers. So for the key fields, we're going to select label, and then we're going to select layer down here, and for the property we're going to use the AutoCAD layer, which is what we made earlier. So we have to do the same thing for the 8-inch PVC. Label, layer, and then AutoCAD layer. Next, and then we're going to build this thing. Close out of that, that's fine. Go ahead and synchronize it. So now you're going to zoom extents, which is this button to your top left. And notice how now our model has been brought in. Except I'm going to go ahead and clean this up a little bit so it's a little easier to read when we start putting in minor loss coefficients and other things like that. So to do this, you can just double click on the label, and I'm just going to get rid of this polyline. And there's probably a way to do this a little faster, but I'm just going to take some time to clean this up real quick. It's kind of annoying. Alright. Oop. Alright. Alright, so that's cleaned up a little bit now. So now for this is our fire hydrant that we had that flow test from. So what we're going to do is we're going to add a reservoir, and then we're going to add a junction from this reservoir to the existing fire hydrant. And then now we're going to add a pump between the reservoir and the fire hydrant. So click on this pump icon and just drop it anywhere in between and hit yes. So then I'm going to clean this up a little bit. Okay, so now we're going to add elevations, and you want your reservoir, your pump, and this fire hydrant to be the same elevation. So now you're going to pull up your DWG that you saved out. So this should have all your elevations if you kept this. So we're just going to put in all these elevations into WaterCAD. So I'm going to move this to my other screen and just look off and put in all these elevations at each of these junctions. So to do this, all you have to do is just click on each one, and this is a little tedious, but you just gotta throw in your elevations one by one. So notice the pump, reservoir, and pump, or the pump, reservoir, and fire hydrant are all going to have the same elevation. Yeah, this is kind of painful, but so almost there. Alright, so yeah, you just have to double check that you have an elevation assigned to every junction, because if not, you're going to get an error when you run the program. So it's just something to keep in mind. Alright, so this is the line going to the Harris teeter. So to mimic this fire hydrant flow, we're going to convert this junction into a fire hydrant just for the sake of the model. So to do this, just click on this hydrant icon and click on junction 9, which is the service to the building. And this is just going to allow us to put in a fire flow demand, which for our case, for the Harris teeter, it's 650 GPMs. So once we have all that set up, we need to go to Analysis, Calculation Options, and make sure you're under Steady State. And now we're going to change this calculation type from Hydraulics Only to Fire Flow. And close out of that. And so from there, we're going to set our fire flow tests, and that is within calculation option. Nope. It's in fire flow down here, base fire flow. So over here, it might vary from project to project, but for the sake of this video, we're just going to put 20. Fire flow needed, so this is our demand, so we're going to put 650. We'll leave that at 3,500. So we'll close that for now, and I'm going to create a selection set. So this is good for, like, it's very useful for if you have like a single family and you have a bunch of fire hydrants or just multiple fire hydrants on the project, but in this case we only have one. But you just click on your fire hydrant and right click and go to create selection set. So I'm just going to call this Harris Teeter. So we're going to go back to that Fireflow tab, base Fireflow. And so the Fireflow nodes, now we're going to just select that selection set that we created. So now we have that set up. And just hit close. So now this thing is ready to be ran as a Fireflow test. But we need to change the material for these pipes and change the diameters. And also we need to look at this backflow prevention location. So this junction 6 is where the backflow preventer is located, and so we're gonna use this GPV to model the backflow, the head loss that will be resulted from that backflow. So we're gonna morph it, and this is actually an 8-inch line, so we're just gonna go ahead and change this diameter to 8. And it kept the elevation. So now we need to do a head loss curve. So we're going to do edit GPV head loss curves, set a new one. I'm just going to rename this backflow. So we're going to need 2 rows. So I'm just going to put 3500 right here. And the reason why I'm doing this is so the system, if the flow varies when the model is being generated, it kind of just produces a big window. So now we're going to go into this spreadsheet that's set up, and it's included in a tutorial file. And so here we have our flow rate demand, and you can look at specs for these backflow preventers. So in our case it's 8-inch, and since our demand is 650, if you just follow this curve, it's basically 10 psi as a pressure loss. So what we're going to do is just put in 10, which it's already in, and so it produces a head loss amount right here, which is 23.07. So now we're going to put in 23.07 for both. So it's just a constant head loss no matter what the flow is going into that backflow. So after you do that, you're going to select that curve that we just made in this valve head loss curve. I'm going to go ahead and save since I haven't done that yet. Let's see. Let's put in DWGs for now. Alright, so now we're saved. So now we need to look at this pump right here, and this is going to apply to the other tab, and this is where we need to pull up the Fireflow or the flow request form, and we're going to put in each respective quantity, and it's going to spit out. So for instance, I'll just set all these to 0. And so just looking at the form that we got back, we're just going to put in each of these numbers. Okay. So notice how now we have some pump curve inputs to put into WaterCAD. So now, let's see, pull this up. We're going to do kind of the same thing we did for the backflow. We are going to go to pump definition, edit pump definition, and now we're going to make a new one. And I'm just going to call this Poindexter fire hydrant. So now I'm going to drag this to the other side of the screen, but you're just going to put in these inputs now into each respective quantity. So shut off 0, 1, 6, 7, 2, 8, 7, 9.93. Okay, so you want to make sure your definition type's a 3-point curve. So once we have that set up, we're going to hit close, and we're going to select the pump division that we just created. So after we have that set up, let's just kind of see where we're at. We'll go ahead and save one more time. We're going to see if this thing even runs, which WaterCAD's known to spit out a lot of errors from time to time, so it's pretty frustrating. So it looks like everything ran pretty well for the first time, but now we need to edit the pipe material and pipe diameters for each respective part of our system. We also need to apply minor loss coefficients. So, excuse me, to do that, we're going to go to analysis. Oh, I'm sorry. No, we're going to go to view, and I think it's flex tables. Yep. Double click on pipe table. And so what's nice is if you set up your layers properly in AutoCAD, this will kind of make things go by pretty quickly. So we're just going to quickly edit all this according to what our system is by just looking at the labels. Okay. Then we have PVC. Kind of tedious, just probably a better way or a faster way, but keep going. All right. And I'm just going to go ahead and set this to cast iron as well, just to max what's modeled for the existing system. And that's where our pump and our reservoir is located. Alright, so after we have that all set up, now we're just going to edit these diameters. And so for where the pump and the reservoir is located, I'm going to make this a huge diameter so it doesn't affect the system too much. So after we have that, now we need to apply our minor loss coefficients. So here we have a T because the system keeps going. So this is going to be a branch. So that's going to be CIP3. So this is also kind of tedious, but it's the general idea. And this is also going through a T. So and this is going to be a line. And then PVC5 is a T for a branch. Let's see. I think we have a gate valve here. So that's going to be PVC5. Oh. Excuse me, it's going to be PVC6. Alright. I'm going to treat this as an open gate valve. So this backflow the head loss was already calculated in the junction, so I'm just going to skip this pipe since it's already being considered in the calculation. So now I'm just going to move on to 8. Let's see. So 9 is also going to be a 90 degree. As is PVC1. Alright, so now we should be good to go. So go ahead and close it out. Save it. And let's run this thing. So now you have something to work with. Excuse me. Alright, close. Go to report. And, oh wait, actually, click on this drop down. You can just hit fire flow report. And notice how our fire flow that was needed, or for the test, the fire flow was providing much more than the minimum. And you can also go to hydrant and pull up some additional information. So I hope this helps. It at least kind of gives you a general starting point, at least, about how WaterCAD works. If there is anything wrong with this model, feel free to let me know. But this is at least a pretty good intro to kind of how WaterCAD works. So I hope this helps, and thanks.